Welcome to week 2 of the AI planning course. We've already learned a lot of things in week 1. For example, I've introduced to you the basic planning problem, which is the problem we're addressing in this course. I've also told you about a technique that is used in many places in AI, but specifically is very important to planning, and that technique is search. Then we've met some of our friends, the dog walker robots, an example we'll be using throughout the course. This was followed by my colleague, Tate, telling you about practical planners and applications where these are used. But planning is not just about finding plans. There's also a context to planning. And this is, for example, what happens before planning, namely the assignment of tasks to planners, and after planning, the plan execution, which is very important. Then we've also seen that there is a range of techniques that are used in planners today. That was pretty much what we've learned in week 1. And now I want to talk a little bit about the website. I've already seen a lot of you have used the social platform that comes with this course, which you can see here. And I would like to encourage you to use the discussion forums to bring up any questions, any issues that you have with the course material. And hopefully some of the community that uses this forum will answer those questions for you, or we, the instructors, can help as well.
In this week's first segment, we'll be looking at informed search, or more specifically, the Astar search algorithm. Astar is a search algorithm just like the ones we've seen last week. It takes an implicit graph and searches it in its basic form as a tree. Shown here is the search tree generated by the Astar algorithm for the Turing-Romania problem, where the task is to get from Arad to Bucharest. What is new here is that the algorithm uses a number to guide its search, and this number expresses how far from the search node the algorithm thinks the current node is. This is called a heuristic. And this heuristic is used to compute some evaluation function that tells the algorithm which node to expand next. In this graph, we see the numbers here, which are the value of this evaluation function. So, what this algorithm does is use an informed search strategy as opposed to the uninformed search strategies we've seen so far. And probably the best known informed search strategy is used in the Astar algorithm, which is what we will see in the first segment this week. In this week's second segment, we will be seeing our first planning algorithm, which is the forward state space search algorithm. This uses the search technology we've seen in the previous segment. As you will see in detail, this algorithm is actually very simple. It takes a planning problem as input, which is these 3 components you see here, and then starts a loop where it starts from the initial state and builds up a plan starting from an empty plan that will satisfy the goal. The first thing it does is the goal test, which is just what we've seen in our search algorithm, so this is the goal test here. And then generates all the applicable actions in the current state. If there are none, then of course we have failed. Otherwise, it just chooses one of the applicable actions. That is our new action that we apply in our state. Then we go to a new state by going forward from our current state and extend our plan with this current action. And we go through this loop until we have reached a goal state, and therefore we have found a plan that achieves our goal. But before we get to this algorithm, we will see a formal definition of what constitutes a planning problem. And most importantly, we will see the strips representation for operators, which is this set O here, which describes an operator as something consisting of preconditions and effects. That's what we will look at later this week.
So now it's time to get into the material for week 2. Week 1 was fairly lightweight, and you've seen an informal introduction to planning. In week 2, we will see the material a lot more technical. We will introduce algorithms, and you will have something to implement if you want.